This is an example of two-dimensional elastic collision. There are two balls, ball 1 and ball 2. Ball 2 is at rest, so V2 is 0. Its mass is 2 kg. Ball 1 is moving to the right, mass is 3 kg. The initial velocity is supposed given. It is like a 10 meter per second, direction to the right. After elastic collision, the two balls separate. They move in their own ways. So angle alpha is given 30 degrees. So the question is, find the angle beta and V1 prime, V2 prime. V1 prime, V2 prime are speeds. They are the magnitude of final velocities. So the starting point is momentum conservation. Momentum P is conserved. Because the vector, that means its components, x component and y component, both are conserved. So we can write down two equations for this conservation. And also because it is elastic, by definition, elastic means EK, kinetic energy, before and after collision, the value does not change. So that means EK final, EK final equal to EK initial. So then we can write down another equation. So in total, we can write down three equations. So that's why we can solve for three unknowns. So let's write down this equation. As component of momentum is conserved, so we can write down like M1 V1 plus 0 because ball 2 is at rest at the beginning. And then the S component of ball 1, ball 2 are M1 V1 prime. We use cosine ratio. And then plus M2 V2 prime times cosine beta. So we can plug in the numbers, try to simplify it. So left side just 3 times 10, and right side is 3 times V1 prime cos 30 degrees plus M2, it is 2, and V2 prime cos beta. So this is our equation 1. So similarly, we can write down the conservation of y component of momentum. So 0 plus 0, because ball 1 moves horizontally, its y component is 0, and ball 2 does not move, so component 0. So ball 1 has a positive component, which is M1 V1 prime. This time we use psi for y component. Ball 2 has a negative component, which is M2 V2 prime. This is the magnitude of momentum. Then we times sine beta, but it's negative, so here we should change to negative sign. This is the second equation. So we plug in number. So 0 equal to 3 V1 prime sine 30 degrees, and then minus 2 V2 prime sine beta. This is our second equation. Third equation is before and after collision. Kinetic energy remains same, does not change. In the middle, they may not be same. And so we can write down initial kinetic energy. Only ball 1 has kinetic energy. After collision, both balls are moving. Both have kinetic energy. Let's multiply both sides by 2, get rid of denominator 2, and plug in number. So then the left side is 3 times 10 squared, so it's 300 equal to 3 V1 prime squared plus 2 V2 prime squared. This is equation 3. So these three equations unknowns are V1 prime, V2 prime, and angle beta. So then we solve these three equations together. Let's put them together. We put a variable on left side, so you got and also 30 degree special angles. So then it is got 2, 3 root 3 V1 prime plus 2 V2 prime cos beta equal to 30. Let's call the equation 4. And then equation 2, sine 30 degrees 1 over 2. So you get the 3 over 2 v1 prime minus 2 v2 prime sine beta equal to 0. Let's call equation 5. So the last equation, this is 3 v1 prime square plus 2 v2 prime square equal to 300. So let's call the equation 6. And then how to solve this equation? Yeah, one way to do that is we isolate v2 prime cos beta, v2 prime sin beta, and then we square both and add together. So then we know sine squared plus cosine squared is 1. So angle beta will be gone. So then we will get a v2 prime squared, and then we substitute into equation 6. So then we will get an equation about v1 prime only. So that means we are going to isolate, we can isolate the 2 together. So keep the coefficient. So 2 v2 prime cos beta equal to 30 minus 2, 3 root 3 v1 prime. And then we square both. Same thing, we isolate 2 v2 prime sine beta which is equal to 3 over 2 times v1 prime. Then we square both sides of the equation. Let's call it 7 and 8. And then we add 7 and 8 together. So then left side, using Pythagorean identities, that will be 4 v2 prime squared. Right side, we just copy down. So then we write down the same point first. So it's 9 over 4 v1 prime squared plus, and then 30 minus 2, 3 root 3 v1 prime squared. And then we can plug v2 prime into question 6. So then what we got is 3 v1 prime squared copied down plus, this is 2, here is 4. So you divide by 2. So you got 9 over 8 v1 prime squared plus 1 over 2, 300 minus 2, 3 root 3 v1 prime squared. And then equal to 300. So then there's only one variable v1 prime. It's a quadratic equation in v1 prime. You just take time, open brackets, collect like terms. If it's not factorable, using quadratic formula, solve for v1 prime. So once you got a v1 prime, then you can plug in equation 6, get a v2 prime. Because v1 prime, v2 prime, they are speed. So then should keep the positive solutions. So once you got a v1, v2 prime, then you can get a cosine ratio or get a sine ratio. Because beta is a acute angle. So then you can take a arc cosine or arc sine to find the angle beta. Because it's simple, so we stop here.